Welcome back. Now, one of the most important tools that we can use aside from logs are debug shapes. Oftentimes, we need to see what's happening and where. For example, when we press play in our game here, we have no idea that there are two actors right there, two BP item objects. Now, usually actors will have their own visual representation. These static mesh actors here have meshes so we can see them in the game. But we haven't added any meshes to our item class just yet, but I'd still like to see where they are in the game. And we can see them by the use of debug shapes. Let's open BP item, and in begin play, I'd like to draw a debug sphere so that we can see where these items are. Now, if I drag off of begin play and type draw debug sphere, there's a function. This blueprint node allows us to draw a debug sphere. Now, drawing a debug sphere requires some information. For one, we need to know where we should place the sphere. In other words, where should the center of the sphere be in 3D space? And you'll see that if we hover over this input, its type is vector. And as we know, a three-dimensional vector has x, y, and z components. This allows us to specify where the center of that sphere should be. Now, next we have some other inputs. Hovering over radius, we see that this is a float, and it has a default value here of 100. Next, we have an integer called segments, and it's set to 12. We have a line color, and its type is linear color. Now, the linear color type is much like the F color that we used in C++. It has red, green, blue information. Now, we can click on this, and we get a color picker, allowing us to specify the color that's used. So if we drag this up and make it blue, well, then we can click OK, and our debug sphere will be drawn blue. Next, we have a duration, and we can set this to a value such as 60 seconds, and that allows us to draw the sphere, and it will linger for 60 seconds before it's removed. And then finally, we have thickness, which allows us to change the thickness of our debug sphere's lines. Let me show you what I mean. I'm going to go ahead and press play. And right here, we see the debug sphere. It's drawn at the origin of the world because we did not specify three-dimensional coordinates, and the default values for that location of the sphere center are 0, 0, 0. So this is showing us the world origin at 0, 0, 0. And we have segments. There are 12 of them, and that's why our sphere isn't exactly round. And with a line thickness of 0, the lines are relatively thin. I'm going to shift escape to come back into BP item. Now, we can change these. Let's say we'd like to draw the debug sphere at the location of our BP item. Well, if we right-click in the event graph, we can type get actor location. And this is a function that all actors have. Let's select that, and we'll see that we have a node here, which has an input called target. And hovering over it, we see that it's an actor object reference. And by default, it's set to self. So calling this function will result in getting the actor location for this particular item. Now, the return value is a vector, and we can plug that straight into the center input for draw debug sphere. Now we're going to draw the debug sphere at our actor location. Now we can change the radius. I'm going to change it to 50 so we get a smaller sphere. And the number of segments is 12, but let's see what it looks like with 24. And we'll leave the duration at 60 seconds, but I'll change the thickness to 1 so we can see what that looks like. And if we press play, now we see two spheres. The reason we saw one before was because we were drawing a debug sphere for each actor, but both of them were drawn at 0, 0, 0. So they were both on top of each other. But now we're drawing them at the location of each actor. And as we can see, the sphere is more round because we have 24 segments instead of 12. And the lines are quite a bit thicker. So now that we're drawing debug spheres, we can see the locations of each actor, even though the actors themselves are invisible. So this is very useful for us as game developers because we may wish to see things that are invisible in the world, but drawing a debug sphere allows us to visualize them. Now, this is great. We're doing this in Blueprints, but we want to know how to do this in C++. So I'm going to go ahead and delete those nodes and head back into my Unreal Engine Visual Studio project. And I'd like to draw a debug sphere from here in the item class. And I'm going to scroll up to begin play to do this. Now, in order to draw a debug sphere, we need to include a header file that has the functions defined for drawing debug spheres. So we're going to scroll all the way up to the top where we have our includes, and we're going to include another header file here. So let's do this. We're going to include draw debug helpers.h. Now, drawDebugHelpers.h has a number of debug helper functions, including a function for drawing debug spheres. We're going to use that here in begin play. Now, the function for drawing a debug sphere is, surprise, surprise, draw debug sphere. And if we open the parentheses, then here's a helpful pop-up showing us the required inputs. And we see that some of them have default values, so we can get away with not providing those ones, and they'll be given the default values for this function. Now, the first input is a uWorld pointer called inWorld. Remember in the C++ refresher lecture, we said that there exists a world, which is a subclass of the package. Whenever we're playing our game, our level exists in a given world. Now, drawDebugSphere needs to know the world that we're in, so we have to provide that world. And the way we can get that world is by using a function called getWorld. And if we hover over getWorld, we see that it returns a uWorld pointer. And the pop-up says, getter for the cached world pointer will return null if the actor is not actually spawned in a level. Now, here we go again, seeing a warning that says that this could return a null pointer, which means that it's usually a good idea to check to make sure that the world pointer returned from getWorld is not null. Now, usually by begin play, the world is valid because we wouldn't be able to spawn this item in the world if there wasn't a world yet. But following good C++ practice, we're going to check that world pointer. We're going to make a local variable of type uWorld. That's a pointer, and we're going to call this world and use the assignment operator to initialize world with the pointer returned from the getWorld function. And then we can be safe and check this pointer. We can say if world. And if the world pointer is null, our if check will fail. So it's really useful to be able to check pointers with an if check to make sure they're not null first. So if we've reached the inside of this if check, we know that our world pointer is valid, and we can pass one in to draw debug sphere. So I'm going to highlight draw debug sphere and click and drag it straight into the if check here, and go ahead and indent it properly. Now, clicking inside the parentheses, I'm going to Control-Shift-Space to see our inputs that we need. And the first, of course, is the world, so we're going to provide world as the first input. Now, draw debug sphere has a second input called center, and this is a const f vector reference. So this brings us to a new type called f vector. And in the editor, when we called getActorLocation, we saw that it returned a vector. In blueprints, it's called vector, but in C++, it's called f vector. So we need an f vector to satisfy draw debug sphere's input requirement. Now, we saw that we could call getActorLocation to get our actor's world location. We're going to do that here, but I'd like to create a local variable of type f vector and call this location, and initialize it using our actor's inherited function getActorLocation. So getActorLocation is a function here in C++ as well. And we see that it returns the location of the root component of this actor. And remember, our actor does have a root component called default scene root in blueprints, and it has a location. That's the location that our actor considers to be its world location. So now that we have an f vector called location, we can pass that in as the second input argument to draw debug sphere. Now next we have a radius. We can choose a radius. Let's choose 25, and I'll use .f to specify that this is a float value. Next we have an integer called segments. Now you may be used to seeing int, but Unreal Engine has int32. Now the reason for this is because the integer data type is usually 32 bits in size, but this could vary depending on the platform. So Unreal Engine wanted to make sure that we're always using a 32-bit integer, and so it created this type as a built-in integer type to the engine, and Unreal Engine makes sure that it's always a 32-bit integer. So in Unreal Engine, when we use integers, we're not going to use the int data type. We're always going to use int32 instead. Now I'm going to pass in a literal value. Let's use 24 for the number of segments here. And then we have our fcolor. And like we did before with our on-screen debug message, we can create a temporary fcolor and specify red, as red is one of those static variables built into the fcolor type. Now, next we see bPersistentLines. It's a Boolean, and by default it's set to false. If we pass in true for this, then we'll have persistent lines, meaning our debug sphere will never go away. If we pass in false instead, then we need to provide a lifetime for the sphere, which is our next input. Now we can pass in 30.f to specify that we should draw this sphere for 30 seconds. And because the rest of the inputs are optional, I can leave them out. So now we're going to draw a red debug sphere. Let's go ahead and save this and hop back into the editor so we can hot reload. Now that hot reloading is complete, let's go ahead and hit play. And there we see our spheres. So now we're drawing these from C++. And this is excellent because now we know how to visualize things that may otherwise be invisible. And this will really come in handy when we're performing our logic in C++. So this is great. Now, it would be nice if we could draw a debug sphere without providing so many different input parameters. Let's say we'd like to be able to draw a red sphere that always has a radius of 25 and always has 24 segments and is always drawn in 30 seconds. Well, we could make a macro for this to make it easier for us. So if we scroll up to the very top, just under our includes, I'd like to show you how to make a function macro. Now we do this using #define. Now #define lets us create a macro. For example, if I said #define 30, then I'm creating a macro symbol called 30. And after the name of the macro, we can specify a value. Now what this means is that anywhere that I use 30 in my code, at least here in item.cpp, the preprocessor will replace 30 with the actual value here that I've provided, the integer 30. So what I could do is come down here to draw debug sphere, and instead of 24 for the number of segments, I could pass in 30, my macro symbol, and this is the same thing as the value 30. In fact, if we hover over it, we see that it expands to 30. That means that at compile time, this 30 symbol will be replaced by the actual value 30. That's how we can define symbols. But we can also make function macros that take inputs. For example, we can define draw sphere, and we can provide parentheses to specify an input. Now, unlike functions, we don't provide the type, we just provide the name of the input, such as location. And then we define what this symbol should expand to. So what we could do is say if getWorld, which essentially will check to make sure that getWorld doesn't return a null pointer first. And then we can call draw debug sphere. And when we call draw debug sphere, we can pass in the value of the world. I'm just going to call getWorld here. So essentially we're calling getWorld once first to make sure that it doesn't return null, and then we can be sure that calling it again will be safe. And then the next input is the location. We can pass in the location input that we specified for draw sphere. And I'd like to put some default values here. We know that the next input is the radius. I'm going to use 25.f for the radius. And for the number of segments, let's just use 12. And for the fcolor, we'll use fcolor red. Now we need to decide if we want persistent lines. I'm going to pass in true so that our debug sphere will never go away. And then I'll put my ending semicolon there. So now we've defined this macro that we can use, and that macro will be replaced with this code. Now, if you haven't seen an if statement all on one line like this, this is legal C++. We can do this very easily. In fact, we could come down here to our add-on screen debug message here and use a single line for this instead of using a block with curly braces, like this. And this would do the same thing. Now, in general, it's a good idea to do it the way we did before with curly braces. That way we can really see what's going on. And if we want multiple lines, we have to have curly braces. But in our case for our macro, we can keep it compact like this. Okay, so we have a draw sphere macro. Let's put this to use. We'll go all the way down to the bottom of begin play here. And instead of all this, I'd like to make my life easier by using my new macro. Now, I could say f vector location equals get actor location and have a local variable called location and use that, and call draw underscore sphere and pass in location. Now, here's an interesting thing. This macro will literally be replaced by this line of code here by the time we've compiled, and that includes the semicolon here. So if I left the semicolon out, this would actually compile and work. Let's see how it works. I'm going to go ahead and hit save and come back into the editor and hot reload. We see that we've compiled successfully, and if we hit play, there's our spheres. And notice that they use 12 segments instead of 24. So it's not quite as round as a sphere with 24 segments, but also the engine doesn't have to draw as many lines, which is more performant. When we use these debug shapes, performance can start to tank really quickly the more debug shapes we use. These are not designed to be used in a packaged game. They're just debug tools. Okay, so we now have the ability to draw a sphere just passing in a location. Now, we know that doing it this way means that we can't choose the number of segments or the sphere radius, we can't choose the color, and it has to be using persistent lines, but that's great. If that's all we want, then this is much easier. Now, this only works here in the item class, so if we wanted to use this, say, in another class, we'd have to define this macro symbol in that class, which is kind of a pain, but in order to use draw sphere in other classes without doing that, we can define draw sphere somewhere else. Now, remember, we have /h and /cpp. If we define draw sphere in /h, then we could use draw sphere in any class that includes /h. So what I'd like to do is take this line where we've defined our macro and cut it with Control X, now I have it copied, and go into /h and just define it here. That way we can include /h in any class and have access to this macro. So this makes it easier for using draw sphere in multiple different classes. Now that means for the compiler to know that draw sphere exists from within item.cpp, we're going to have to include /h here. So along with draw debug helpers, I'm going to include /h, which exists in the slash folder, and here it is, /h. So now that we've included /h, this macro called draw sphere will work here in item.cpp. Now we don't have to type so much. Let's go ahead and save this and go back into the editor and hot reload. And with a successful hot reload, we can press play, and there are our spheres. So this is great because now we can draw a sphere very easily using our new macro. Great job. I'll see you soon.